Transforming polynomial functions. So we've talked about this a few times before, but we just want to apply the transformations to the different polynomial functions we've been discussing. So remember, f of x is just the general parent function we're talking about, and then this gives you the general form of the function with all of the transformations. The horizontal shift is determined by the h. So remember, it's always the opposite sign of what it looks like in here because it's given to you as a subtraction. So if you have a positive h value, we're going to move to the right that number of units. If you have a negative h value, we're going to move our graph to the left that many units. The vertical shift is based off of the k, and that's the one outside of the parentheses. And it's going to be the same sign as what it looks like. So a plus k value is going to move us up. A minus k value is going to move us down. The reflections, there are two different types that we can have. If the negative is outside of the parent function, the f of x, then this is going to be a reflection over the x-axis. If the negative is inside of the f of x and it's with that x, this is going to be a reflection over the y-axis. And we've talked about the vertical stretch and compression before. It's that number multiplied on the outside of the function. And remember, we're always talking about the absolute value. So if the absolute value of a is greater than 1, then this is a vertical stretch. And then when the absolute value of a is less than 1, it's a vertical compression. And remember, when we talk about the vertical stretch and compression, you always have to say what the factor is. So if it's by a factor of 2, by a factor of 1/2, make sure that you list that as well. So here we just want to name the parent function and the transformation steps that have occurred. So in this first example, the parent function, we want to look at that x with the exponent. So here we have a parent function of y equals x squared. Is there a horizontal shift? We don't have a set of parentheses around that x with a horizontal shift inside, so we say none. Or we can say there's a horizontal shift of 0. A vertical shift, this is the one outside, and so it's going to, because it's positive, it'll go up 2 units. And then the stretch and compression, we want to look at that number multiplied in front of the x. We don't care about that negative because we're just looking at the absolute value. Since this is less than 1, we're going to say that it's a compression by a factor of 1/3. And then a reflection, so we're looking for that negative, and because it's outside in front of our a, that's going to be over the x-axis. So I'll walk through one more with you. In this next one, again, we see the x and we have an exponent of 2, so our parent function is y equals x squared. The horizontal shift is the one inside, it's opposite direction of what it says. So negative means positive, so we're going to go to the right 3 units. The vertical shift is the same as the sign on the outside, so we're going to go down 1 unit. When you look at the a, the absolute value of a, it's greater than 1, so it's a stretch by a factor of 2. And a is not negative and the x is not negative, so we have no reflection. In example 3, we have x cubed, so our parent function is y equals x cubed. Our horizontal shift inside, opposite sign of what it looks like, so the negative direction horizontally is to the left 6 units. Vertical shift, we don't have anything. And then stretch and compression, absolute value of a is 4, which is greater than 1, so we have a stretch by a factor of 4, and then we have this negative outside, so this is going to be a reflection over the x-axis. Now for the last example, we have x to the fourth, so our parent function is y equals x to the fourth. We don't have a horizontal shift inside. Vertical shift, negative, means we're going down 12 units. Here, the absolute value of a, 2/3, that's less than 1, so we have a compression by a factor of 2/3. And lastly, we have this negative outside of our a, so it's going to be a reflection over the x-axis. Here we're given the parent function with a list of transformations, and we need to write the equation of the function after the transformations. So we have a parent function of y equals x cubed, with a reflection over the x-axis, vertical shift down 3 units, and a horizontal shift right 2 units. So when we write our function, we have y equals, that reflection over the x-axis makes a negative in the beginning. We don't have a vertical stretch or compression, but because we have a horizontal shift, we need to put parentheses before we write our parent function, x, and then right 2 units. Right is the positive direction, but remember, when we're putting the horizontal shift inside, it needs to be the opposite sign, so we're going to put a -2. This is cubed, and then the vertical shift down 3 units, that's in the negative direction on the outside. So here's our equation. Let's walk through the second one together. The parent function y equals x to the fourth. It has a vertical stretch by a factor of 2. So remember, this is going to be our a in the very front. We have a reflection over the x-axis, which makes it negative, and then a horizontal shift left 1/2 units. So we start off with y equals, the reflection over the x-axis tells us it's going to be negative, the vertical stretch by a factor of 2, and then because we have the horizontal shift, we need parentheses, x, and then to the left is in the negative direction, 1/2, so inside we're going to write positive 1/2, close our parentheses to the fourth, and we don't have a vertical shift. Now I want you to try example 3 and 4 on your own and check back with me when you're finished. So in example 3, here we have our vertical compression by a factor of 3/4, the reflection over the x-axis, and the vertical shift up 6 units with our parent function x squared. And in example 4, we have the vertical stretch by a factor of 3, the vertical shift down 5 units, and the horizontal shift left 2 units. Remember, left is in the negative direction, but we have to make it the opposite sign inside. And then we have that parent function x cubed. Hopefully you got those 2 right. This brings us to the end of our notes for this section, so I'll see you in class for more practice.